Today in math, we'll be discussing why the sum of all natural numbers, namely 1 plus 2 plus 3 plus 4 plus 5 plus all the way to infinity, is equal to negative 1 over 12. So our goal is to find s, which is 1 plus 2 plus 3 plus 4 plus 5, and so on all the way to infinity. Now, in order to find what s is equivalent to, we're going to use two other sums. One we'll call S1, and S1 will be equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on, all the way to infinity. Now the second sum will be S2, and S2 will be 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, and so on all the way to infinity. Now we're going to start off with evaluating what S1 is equal to. So we have our sum S1, and you might be tempted to think that S1 should, or at least it makes sense to equal 0, because we can see that the first one and the second one cancel each other out, and so on in pairs, and they all come out to be 0. So it seems like S1 should equal 0. However, S1 does not equal 0. And we'll figure out what it does equal. It turns out that S1 is actually what's called a geometric series. Geometric series. What it means to be a geometric series is that a bunch of terms are added together, but to get from the first term, 1, to the second term, negative 1, we multiply by some number r. And to get from the second term to the third term, we also multiply by r. So to get from each term to the next, you multiply by some number, which we'll call r. In this case, for S1, r is equal to negative 1. Now, what we find is that in general there is a formula that tells us what the sum of all these terms are, a general formula, which we'll show now. We have a geometric series we'll call S sub g, and it's equal to the first term, which we'll call a, plus a times r for the second term, plus a times r again, so ar squared plus ar cubed, plus all the way, and so on. And we can see that to get from the first term to the second term, we multiply by r. From the second term to the third term, we multiply by r again, and we continue doing so. So each term is composed of a times r to some power. Now, what does SG equal? Well, let's do one thing. Let's multiply SG by r. So we have r times SG. Now what is this equal to? A, the first term, becomes a times r. AR becomes AR squared. AR squared becomes AR cubed. And AR cubed becomes AR to the fourth. And so on. Now, what if we subtract these two? So what if we have SG minus r times SG? Then we can see that this equals to A, and all the AR terms and everything are all canceled out. So we find that 1 minus r times s sub g is equal to a. So we can conclude that SG, therefore, is equal to a over 1 minus r, where a is the first term and r is the ratio between any two consecutive terms. So now we've discovered that for a geometric series, S sub g, it is equal to the first term, a, divided by 1 minus r, where r is the ratio between any two consecutive terms. Now, let's see if we can apply it to S1. So for S1, we find that a is equal to 1, which is the first term, and r, the ratio between terms, is equal to negative 1. Since from 1 to negative 1, we multiply by negative 1, from negative 1 to 1, we multiply by negative 1, and so on. So we can conclude, therefore, that S1 must be equal to A, 1, over 1 minus R, so 1 minus negative 1. And we can simplify that to become 1 over 2. So we find that S1 is equal to 1 over 2. With that in mind, now we can move on to S2. So now we figured out that S1 is equal to 1 over 2. So now we're going to evaluate what S2 is equal to. So now we have our sum, S2, which is equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. Now, in order to figure out what S2 equals to, why don't we try adding S2 to itself? So we have S2 plus S2. This is equal to 2 times S2. And this is equal to, and we're going to write it a little differently, 1 minus 2 plus 3 minus 4 plus 5 minus 6, so on. Plus the second S2, which is plus 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. So we have 2s2 is equal to, and what happens when we look at the right hand side? Now I've lined up 1 is by itself, and we have negative 2 plus 1, that's negative 1. We have plus 3 minus 2, which is positive 1, minus 4 plus 3 minus 1, plus 5 minus 4 plus 1, minus 6 plus 5 minus 1, and so on. And we find that this looks exactly like 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus this looks like the sum S1, which we know already to be equal to 1/2. So we find that S2 divided by 2 on both sides is simply equal to 1/4. Now we've discovered that S2 is equal to 1 over 4, and now we're ready to figure out what S is really equal to. So now we finally have our sum. S is equal to 1 plus 2 plus 3 plus 4 plus 5. Now in order to figure out what it's equal to, what if we try subtracting S2? So we have S minus S2 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and so on, minus, and here we have a bracket, 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, and so on. And this in brackets is S2. Now what we find is, we find that S minus S2 is equal to 1 minus 1. They cancel out, so we get 0. We have positive 2 minus negative 2, which is positive 4. We have positive 3 minus 3, which gives us 0. We have positive 4 minus negative 4, which gives us plus 8. 5 minus 5 is 0. But 6 minus negative 6 is positive 12. 7 minus 7 is 0, and so on. Now, this doesn't really seem like we're getting closer to what S is, but let's have a look at what's on the right-hand side. If we factor out a 4 from every term, we find something interesting. We end up with 4 divided by 4 is 1, plus 8 divided by 4 is 2, plus 12 divided by 4 is 3, and so on. But what is 1 plus 2 plus 3 plus 4 and so on? It's S, so we find that S minus S2 is equal to 4S. Now solving for S and plugging in S2, we find that S minus S2 is 1 over 4 is equal to 4S, so 3S is equal to negative 1 over 4. Therefore, we conclude that S, dividing by 3 on both sides, is negative 1 over 12. Namely, the sum of all natural numbers, 1 plus 2 plus 3 plus 4 plus 5, all the way adding up to infinity, is equal to a negative rational number, negative 1 over 12. And so, we have shown that the sum of all natural numbers is equivalent to negative 1 over 12.